When a model performs poorly, the problem is often not the algorithm itself. More often, the issue starts before training even begins. The data the model sees already contains built-in bias. A model is not a human. It has no common sense and no prior experience. For a model, data is reality. That's why, before choosing an algorithm, there is something more important: making sure the data reflects the real world in a reasonable way. That work is called data preprocessing. Data preprocessing may look messy, but at its core, it does only three things: filling gaps, correct bias, and align scale. Each one is about making judgments on behalf of the model. First, filling gaps. Missing values are not mainly a technical problem. They are a trust problem. When a key value is missing, the real question is not how do we fill it, but whether this data point is still worth learning from. Some missing values happen by chance. Others reflect real limits or behavior in the real world. Whether you fill them or remove them directly shapes what the model learns to trust. Second, correcting bias. Handling outliers. Outliers are not always wrong, but if they are added to training without judgment, a small number of extreme cases can strongly influence the model. A model does not know what is typical or rare. If a value appears, the model treats it as equally important. In that case, just a few extreme values can shift the model's overall decision boundaries. Handling outliers is not about making the data look nicer. It is about stopping the model from treating chance events as general rules. Third, aligning scales. Different features often live on very different number ranges. H might be in the tens, income in the hundreds of thousands. If you do nothing, the model will naturally give more weight to larger numbers. The goal of normalization is simple. Remove scale differences so all features are judged on the same level. This does not remove information. It allows the model to focus on structure, not raw size. So data preprocessing is not about directly boosting performance numbers. It is about defining the version of reality the model is allowed to see. A model never learns the real world itself. It learns the world as shown through data. One final takeaway: data preprocessing is not a technical detail. It is how you build the model's basic understanding of the world. When that understanding is sound, only then does learning truly make sense.